We will now proceed with the next lesson, which is Tools for Stream I/O. Talking about tools for Stream I/O, this is used to control the format of the program's output. As you have seen in our examples, of course, we just output whatever the results of our program are into our screen or into an output file. And actually, there are other ways to make the output of our program more appealing. So that's where we can use the various tools for us to format how our output would look like in a file or on our screen. We can use commands that determine such details such as the spaces between items, the number of digits after a decimal point, the numeric style, so we can actually display those numbers in scientific notation for fixed point. And we can also show digits after a decimal point if they are zeros. We can also do it to show plus signs in front of positive numbers, or even left or right justification of numbers in a given space. So those are some of the things that we can do in order for us to format the output of our program, which is of course to make them more appealing or more readable for its users. Now we talk about formatting output to files. So to format output to the screen, remember that we did the following. So we have the following functions we can use to format a file using the outFile stream. So for example, we have the outstream set flag iOS fixed, outstream set flag iOS show point, and of course another function in which we can set the precision of our numeric output. We will deal with more of that as we go. So let's first talk about the outstream.precision function. So the precision, if we will recall, is a member function of output streams, such as this one. So what it does is, it will show a total of 2 significant digits, such as the following, or it will show 2 digits after the decimal points, just like this one. Calls to this function would only apply to the stream named in the call. And the other one, setf, is a member function of output streams. Setf is actually called as set flags. A flag is an instruction to do one of two options. So how can we use this in C++ programming? So we can use the following flag. So for example, we have the outstream object. We can simply call its setFlag function and provide the following argument. So the following argument will provide the value for the flag that is required. And all further output of floating point numbers will be, first, written in fixed point notation, the way we normally expect to see numbers. Calls to set flag apply only to the stream named in the call. So for example, for every set flag function that you call, that would only apply or take effect to the stream that was named in the call. So for example, in the case of outstream. And another one, the show point flag. After we call setFlag function, with the following flag, in this case, IOS show point. The output of floating point numbers will be, first, it will show the decimal point even if all digits after the decimal points are 0. If we would like to see the details of how the following flags work and what they specifically mean, we can take a look at this information. So I guess you can just read the details by yourself that was provided in the course materials that was given to you. Now, talking about creating space in your output. Of course, there will be times that you will need to put extra spaces in your program output to make it more appealing and of course to make it more readable. So there are actually a couple of I/O tools that we can use to accomplish the task instead of manually typing in the space in your I/O routines. First, one example of that is the width function, which specifies the number of spaces for the next item. And it applies only to the next item of output. Here's an example. Let's say we would like to print the digit 7 in 4 spaces, so we can do the following. So, for example, we have outstream as our stream object. So as we've mentioned a while ago, whenever we call, for example, the width function, this will only affect the stream that was called in the following statement. So let's say we typed in outstream.width 4, then we would like to output the number 7. So what will be the result? So for example, since we are only trying to output a single digit and we set the width to 4, so this is what will happen if we use the following flags. So let's say use the following flag, IOS right, as compared with using the IOS left flag. So this is how spaces will be output using the following. But what if the output is much bigger than the width or space that has been provided? So that might leave us with not enough width. So what if the argument for width is too small? For example, we specified that the width was only 3. However, as we can see here, the value that we need to print is much bigger than that. So what will happen? Of course, the entire item will always be output, which means the entire output will always be displayed on our screen or written to a file. If 2 spaces are specified, as many more spaces as needed are used, so which means if the width or space that you initially provided is too small, of course, your compiler will automatically adjust in order for our program output to fit in. And of course, whenever we use flags, they will be up in the entire execution of your program unless you turn them off. Or we do that by unsetting our flags. Any flag that is set may be unset. To do that, we use the unset flag function. For example, we would like to stop the flag for this. So previously, we set a flag and provided the following argument. To turn off or unset that flag, we simply call the unset flag function. So this will cause the program to stop printing plus signs on positive numbers. We also have what we call manipulators. A manipulator is a function called in a non-traditional way. For example, manipulators in turn call member functions. But how does that happen? So in a couple of examples, we will see how. Also, manipulators may or may not have arguments. They can be used after the insertion operator as if the manipulator function call is an output item. For example, we have the setWidth manipulator. The setWidth does the same task as the member function width. So if you will recall from the previous slides, we use the function width to set the initial space that will be provided to our output. But of course, instead of calling the function width, we can simply use a manipulator such as the setWidth manipulator to do the same. So it calls the width function to set spaces for our output. For example, we would like to output the following. So as you can see here, instead of calling the width function, we simply call the setWidth manipulation and provided the argument which would specify the width or the number of spaces that will be provided for the next output. So for example, we would like to output the number 10, but prior to that, we set the width to 4. We would like to output the number 20, and prior to that, we set the width to 4, and so on. So if we're going to run this piece of code, the output will be the following. As you can see here, for example, we output 10. So since 10 is 2 digits width, we're only left with 2 spaces. Same also for 20. And in the case of 30, since we set the width as 6, so we are only left with 4 spaces. And we also have the setPrecision manipulator. setPrecision does the same task as the member function precision. For example, how can we use that? In this case, we set the following flags for our cout object, for our cout output stream. So for example, we set the flags as fixed and show point. However, in this part, as you can see here, instead of calling the function precision, we simply used the setPrecision manipulator and indicated the number of digits for our numeric precision. Hence, if we run this piece of code, this will be the output. So as you can see here, an extra 0 was added since we set our precision to 2. Thus, the setPrecision setting stays in effect until changed. So unless we change our precision to another value, it will remain to this value until changed. So, how are manipulators defined? So the manipulators setWidth and setPrecision are defined in the io-manip library. So if we will recall, just like any other functions that we used previously, they also have their corresponding library that needs to be included. So in this case, if we would like to use the following manipulators, for example, setWidth and setPrecision, we need to include the io-manip library in our program by providing the appropriate include directives, such as this one.